All right, welcome to Cojo's Math, and today we're talking about similar prisms. So you say, what are similar prisms? Well, they're like similar figures, and there's two things that you need to be able to recognize with similar prisms. And that's the 3D polyhedron we're talking about. What makes them similar? One, they have to be the same shape. And two, and the most important thing is, because sometimes it's hard to tell, the corresponding dimensions have to be proportional. That makes two prisms similar. They have to be proportional. Now you think back to what proportions are. Key word, similar fractions that you set up and you use cross products property to solve and find a missing part. So similar prisms have to have the same shape and they have to be proportional. So their measurements, their corresponding sides measurements have to be proportional, so they grow or they're comparatively in the same way. But all the sides have to be proportional, just not one or two. So here we go. Here are two prisms. At first glance, are they similar? No, they're not the same shape. This one's short and squat, and this one's not. But you may say, and then you have to look, you say, this goes 4, 4, 1, and this goes 1, 1, 4. So let's say you were saying, well, maybe this is standing up and this one isn't, so let's check it. So you have to check it to make sure, because you're not quite sure. You want to be careful. So you want to test the mathematics part and see if the corresponding dimensions are proportional. So we go 1 to 4. So when we compare, we'll say, okay, I'm going to go from left to right. So this is the front, this is the front, so I'm going to compare this one, 4, 2, 1. I'm going to compare this side. Now this is the depth, this is here, and I'm going to go 4, 2, 1. And then I'm going to get here, the height. And the height goes 1, 2, 4. This is 4 to 1, this is 4 to 1, but this one's 1 to 4. They're not similar mathematically, so they're not proportional. Because if they're not proportional, they're not similar. Back and forth. All of these fractions have to be the same. And what that means is, for every 4 parts on this one, there's 1 part on this one. Now that's important if you're creating a model of something, or and you're going to build it, and you want to show it to scale of how it's really going to look. And we've talked about that, right? So it's the same thing, and now you use them with polyhedrons or prisms. Well, how would you do this one? You would compare them to see if they're similar. So when we compare them, this is how you show your work. You would compare the sides. You're going to be doing height, length, width, and height. You have to write that down. You'll have to write those 3 things down to compare them. And this one, the length is 4, and the width is 4, and the height is 2. When we come over here, under this one, because what I'm doing is I'm writing this length, width, and height. Now you might say, well, which one's the length and which one's the width? Whichever one you determine is the length and the width on this one, you want to do it in the same location on that one. So if you went, this is the width and this is the length, that's okay as long as you made this the length and that's the width. So now the length, if this was 4 and this is 2, if this is 4, this is 2, and if the height was 2, the height is 1. Now we write fractions, proportions, to see if all the fractions are the same. 4 over 2, 4 over 2, 2 over 1. These simplify to 2 over 1. So now you look, we write length, width, and height. You write the measurements for those, then you write them as fractions and simplify. If all the fractions are the same, then the two prisms are proportional, and they are similar. That's all you do. So, are these two rectangular prisms similar? So they're telling you that it's a rectangular prism. They're not showing you a drawing, but they're telling you that they're two rectangular prisms. So that's telling you that the two shapes are the same. So now what do? You write down 12 over 15, because I'm comparing it the length to the length, the measurements, 16 to 20, and 8 to 10. Now, what do you have to do with those three fractions? That's right, you have to simplify them. That's what I've been telling you all year. Simplify fractions all the time. So 12/15 becomes what? What does 12/15 become? What goes into 12 and 15? 3. So it becomes 4 to 5. And remember, we read them as 4 to 5. Not 4/5, but 4 to 5, because on this rectangular prism, for every 4 units, this one has 5 units. Now, 16/20, 4 goes into both of them, so it's 4/5. And 8/10, 4 goes into both of them, so it's 4/5. Are they similar? Yes, but you have to prove it. So you would write this on your paper. You could drop that and just put a second column, like I did. Wait, where did it go? Like I did here, length, width, and height. You write the first one. You write the second one. Maybe we would put first here, second, so that you could keep your material organized, your numbers organized, and then you write the fractions, the proportions. And you have to write yes or no. That's your proof. So sometimes they'll tell you these two prisms are similar. And they'll say, find the missing side. Well, now you always use, in that situation, proportions. We learned that a long time ago. So you set two fractions equal to each other with the missing part, and you use the cross products property. Remember the cross products property, I hope? Let's see, you're supposed to. So, whenever they want you to find a missing measure, they have to tell you that the prisms are similar, or you have two rectangular prisms, so you know what you're working with. So here we go. The prisms are similar. Duh. Find the missing measure. So here we go. Now here, notice what I put. We have prism A, prism B. 8 inches, 13 inches, and M inches. This one is 10 feet, X feet, and 90 inches. Uh-oh. What's wrong? This is inches, that's inches, those two are feet. Got to be careful. So we're going to have to set up proportions to solve those, but we're going to have to convert this to inches. And when we find this answer, it's going to be in inches, and we have to convert it to feet. Very good. Okay, so let's do it. So we have to set it up. We'll start with this one. So we have to find the one that we know. So this one's missing a measurement because we have to find the fraction, the one proportion that matches with each other. We need at least one of the proportions, one fraction, that has both parts. The length has both parts, but we need to change this to inches. So how many inches are in a foot? 12 inches in a foot. So now we go 12 times 10 is 120 inches. So we're going to say 8 over 120. Well, you know what I'm going to do? I'm going to simplify that because I don't want to work with that. Even though you can use a calculator, I don't want to work with that. So 8 goes into 120. Do you remember that? It goes in how many times? 15 times. So I'm going to change this to 1/15 because 8 goes into 12 one time. 8, 12 minus, yep, that's right, 1/15. So now we have our one fraction that we can use, but this is in inches, remember. This is in inches, and we want to get this in feet. So now we go, okay, How do we write it? We say 1/15 equals, because that's our ratio, our proportion for one measurement. And then we go 13 over x. Because we're comparing 8 to 120, which is 1/15, 13 to x. Get our calculator, and we do cross products property. You have to show your work. X equals 13 times 15. 13 times 15 is 195. That's easy. 195 what, though? That's not 195 feet. That's 195 inches. They want feet. So what do? Divide by 12. And you have to show me that. And it becomes 16.25. So you go up here and say 16.25 feet. Now I'm going to stick with inches on this, because this one's in inches. And I need to find m inches. So I still use this, because that was what I got from the original thing. To solve this one, I have to use the same fraction. So this is m to 90. So I go 1/15, because that's my portion, and then I need to know m over 90. Because see, this is what they want me to find. But they want me to find it on Prism A. Okay. So I go cross products property, 15m equals 90. Now I have to show my work. I divide both sides by 15. Remember the miniature fractions you have to make? This cancels, and m equals, well, how many times does 15 go into 90? 6. And what's the answer? 6 inches. So m, you come back up here and say m equals 6 inches. We don't need to convert it to feet because they want it in inches. That's what you do. Okay? So those are similar prisms. 1, they have to be the same shape. 2, they have to be proportional. Their dimensions have to be proportional. This is what you're going to be doing in class tomorrow. Write down 2 things you learned and 1 question you still have. Bring them to class tomorrow. You'll have discussion, and then you'll work in groups and do your homework collaboratively in class. Have a great day. Let me turn my camera off.